Hello, this is Robert Gadarian. Today we are talking about functions, and this starts our venture into functions. And this starts off with the fact we've seen them. So math.square root, random.randint, math.pow. We've seen just all of the built-in functions, including int and stir, print. These are all functions. So what do they do? How do they work? We've been playing a little bit fast and loose with it until now. That's what we're going to look into today and for the rest of the week. So the idea here is that you are doing one thing well. What we've seen so far is that we have a big, huge, long list of code and some loops, and it runs from top to the bottom, with the exception of loops that will repeat some of our code for us. And our code has been fairly straightforward. In the last lecture, I even repeated some code. I was like, hey, let's count, or I guess find the distinct words between two books. So I made two sets, and I had some copy-pasted code, and I said, I hate this. That's because I don't like doing the same thing twice. What I would like to do as a programmer is write the code once, and then have that get called a bunch of times, and I can just pass it a parameter. Consider square root. There is a mathematical way to calculate that. And imagine having to paste that into your code every time. Or power. Well, we could manually do power of 2 very easily, right? Or even power of 3. It's a loop. But imagine having that loop to do powers every time you're using it. Ick. It makes your code longer and harder to read. What functions will do for us is solve that problem by letting us call it and do one task for us and do it well. And then we can know that that one piece of code will always do the same job and will do it well. So we can solve that problem, and then later on when we have that problem again, we can just be like, I'm going to call this function. And then it will do it for me. It will return a response that I will know is correct because I've written that code before. I got all the bugs out. I trust it. And that's what we've been doing with these library functions like math.pow and math.square root and math.sine. You assume they work, right? Now we're going to be doing those favors for ourselves. This is the act of being lazy. And that's excellent. A good program is a short program. Short programs probably have fewer bugs. So if we can have a nice, short, tight program, chances are it's actually right. This is called functional decomposition, and it's the art of decomposing an idea into its sub-pieces. I know that this needs to do this, 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 and this. I can write a function for these 4 things, and then I can Lego them together later. Okay, that's a good idea. That's a really good idea. And there's always syntax. It looks like this. We have a new keyword. It's called def. It defines a function. We have to give a function a name. I named mine function name because I'm creative. Then we have smooth braces. And we've seen these with functions before. Math.square root had braces. Math.pow and the built-in pow has smooth braces. Print has smooth braces. So we have already seen this, and we know that that's what it implies. Even string methods, they have braces. So string.split, braces. We have a new keyword in return. A function, we're going to eventually pass it data. Today's lecture, we're not going to be passing parameters. That's next lecture. And we'll be passing it some data or asking it for something, and it will give something back to us. So if we say, hey, math.square root, what's the square root of 4? It's going to say 2. And you'll be like, yay, I don't have to do that myself. What about 9? 3. Perfect. A nice back and forth. You ask it a question, it gives you a response. So that's what this return does. It is what we send back. Some kind of response to the question. There is a code paragraph. This should be no surprise. Guess what? When you dedent that, then the code paragraph is over, meaning that the function is over. This is exactly like a if statement. It's exactly like a while loop. It's exactly like a for loop. So that syntax carries through. So we have some new things, but a lot of repeated ideas. So let's break this down a little bit. That first line, def function name. We name a function. So maybe name it something meaningful. Maybe more than sqrt. That's a little bit too lazy. So I can have a function, and I want to write them before my code. So I'm going to have a function that will ask for input and then repeat it to me. Something easy. So repeater. Hey, that's a good name. So I have these braces. We'll actually put something in those smooth braces soon. And then we have our code paragraph. What are we doing? Well, I'm going to say, about to name it input. That's the function name I need to call. Words is equal to input. Dummy says what? And of course, the person is going to say what? And they will return what? And then we will say print, haha, you said, and then we will, do I want to use string appending or string formatting? I get to choose now. I'm going to just append it because I'm feeling a little lazy. And then I dedent, and life's good. It is telling me that I've done something wrong. That's nice. Okay. What do you want? I'll let you get a view into my whole world here. Words versus word. Sure. Now I have my, I'm now going to call a main line. So what Python is going to do, and I'm jumping ahead a little bit, I'm sorry, is it's going to read in this function, and then it's going to know about this function. Then in my main line, I can call repeater. And it's going to take my input. And it says, dummy says what? What? Ha ha ha, you said what? I'm a dummy. Nah. Now, in my main line, I can actually just call this a bunch of times. Of course, I'm only saving one line of code. These methods can get long, very long. And then I could put this in a loop too. Dummy says what? What? I don't get it. This is a dumb joke. Make it stop. There you go. So it's the idea that this function is doing one thing. Now, one thing I cannot do, because Python is an interpreted language, I cannot do this. And it probably will yell at me right away. In fact, it does. Saying that undefined named repeater. And you're like, well, it's right here. I can see it. Python hasn't gotten there yet. It reads our programs like it reads a book. It's going to read it from top to bottom. So I said, hey, repeater. And it doesn't know what repeater is. It's going to read that in next and then learn about repeater. And only after it knows about repeater can I call it. Now, that's very important and something that's very subtle. There's a new optional thing. This came out with Python 3.5. You can have a hint. You have this funny arrow and you say it returns a string. It does not enforce this in any way. And this brings up the PEP document that says, hey, we can do this. But it is not enforced whatsoever. And I have my brackets on the wrong place. I've never actually used it to date, and I probably will not use them in this course. This is for visibility. And in case you do see it, you can use it. It is kind of a kindness to future versions of yourself. When you're looking at this function, you say, what does this return? Oh, it returns a string. Probably. We don't actually know. Code paragraph. What can we write here? Anything. And this is an important thing. I've already said this about if statements and while loops, but there is no limitation to what we can write inside of a method or function. I will use those terms interchangeably. Officially, these are functions. Methods are functions attached to objects. I apologize if I ever mix the two. So do you want to write your entire program in here? Okay, you can do that. Do you want to have big loops and lots of other stuff in here? You can do that too. So it is very flexible and will let us do pretty much whatever we want. I've never met a limitation. Finally, this return statement. Literally what the function returns. So we're asking any questions, it's something, sending something back. And I actually had math.square in an example I said earlier this lecture. That's okay. I want to see it in our code. So instead of repeater, I can call this get input. And then it'll say, haha, you said something. And they can return that. And that return comes back to wherever we called it. So think about calling math.square root. So x is equal to, I have to import math. Math.sqrt. I'm going to do 9. When we call this function, this runs first and then assigns whatever it results to into x. That is true for our code too. I'm going to call this function and whatever it returns is going to go here. The returned value is a generally bad variable name. In this case, I'm just proving a point. And then I can even say print the returned value here. And it will happily run this code and it will say, haha, you said blah. It will return whatever I said. And then it will print it out here too. So if I run this and rename my function, dummy says what? What? Haha, you said what? Then I have that same string passed back to me, and I'm storing that in the returned value. And you can see it here. And unfortunately, I cannot make this bigger. Or can I? No. So that is returned to us. So that's a very important idea. So we could have mathematical functions that do some very complex math that's really icky, and we don't want it in our main line because it's too complex. What eventually we want in our main line is basically a script. Go do some work, that's hard, and return this back to me. Okay, do some other hard work, return it back to me, and then finally call a third function that puts it all together and returns that back to me. So our main line would be 3 functions. Our program might be 100 lines of code, but our main line is just the high points. I want to do this, this, and this. Or we shouldn't really have our entire program in our main line. That's really not what it's designed for, now that we have functions. All right, write a function that computes the volume of a box. I'm going to jump back to this next time because we actually don't know how to pass in arguments. Sorry about that. Returning multiple items. We can do this. Python lets us do anything. This is quite unique to Python and actually breaks computational logic in general, but it does it in a clever way. And the simplest method we could write is something like this. Return 1, 2, 3, and 42. Oops. So then I'm going to have simple is equal to simple method. So what is going to be inside simple when we're all done here? Let's find out. Dummy says what? What? And simple now has a value and it has a tuple. So if you think about tuple, we can actually verify that too by calling type on simple. Actually, it says it up in my browser variable explorer. And there you go, it's a tuple. So it is using packing and unpacking to do this. We have more than one thing. When Python sees all these commas, it'll put into a tuple and then returns a tuple. So it still does only return one thing because that is a computation standard. That is true for every programming language. You cannot return more than one thing. There's very important reasons for that. You'll find out in 2280 if you're taking the computer science program. I believe there's an engineering equivalent. Yeah, I could even, if I know that it's returning 4 things, I could say 1, 2, 3, v, 4, and I'll use tuple unpacking. I know that this returns a tuple, so therefore I can unpack my tuple into these things. And this is a very Pythonic thing, and I would never actually do this because I don't like it. But you can see up here 1, 2, 3, 4 out of order because of the way it's ordering by name. And it's got all my values as expected. So we can use tuple packing and unpacking here too, just like we showed when we showed tuples. It's kind of neat. Wow, I am so creative. Here's my get input function. Great, uncreative or predictable? I'm not sure. Functions calling functions. Can we write functions that call other functions? Yeah, we can. And there'd be good reasons to do this too. Think back to our example of reading in all of a book and then getting a set of all the words. Well, that would be a very good function once I know how to pass an input, and I'll show you that next time, I could read in a whole book and then have that function return a set of all the words to me. And then I can call that function again with the second book. I can call a third function that will do the actual difference for me. And I could have those function calling a function. So I might have a function that is past a list of all the books, and I want to know what word is in all of these books. And it would happily run a loop for me calling get unique words, and then that function will return a set to me. I will do that example next time, but I want to plant the seed early because again, we can break down subproblems with its subproblems and those subproblems to their subproblems. A good method, and I don't fully subscribe to this, and this is a quote from Martin Fowler, a good method should not be more than 5 lines of code. And in this case, he said method because he's a very object-oriented programmer. Once we start talking about objects, you'll see how he gets there. So in Martin Fowler's opinion, this is a good function. It's an okay function. So functions allow us to do one idea and do it well, and it returns a value. Next class, we're going to talk about passing it arguments so it can do different work on a different input set, but it still does one idea well and will return a value to us. Have a good day.